Can you see my screen?
Yes, please.
Okay, great. So, welcome to the class. It's going to be more interactive. I'm going to make it more. Uh, I'm going to present it in such a way that it will be easier for everybody to understand. And you are free to ask questions. Yeah, so this is the time for you to ask questions. I'm presenting it in such a way that it's going to be more like as if I'm doing some kind of work with you, like one-on-one tutorial class kind of or teaching. So you are free to ask questions. If you have any question that you want to ask, you are free to ask it. Yeah, so if you have any question, you are free to ask. So we start straight by going into what a FSE is. Yeah. So what is FSE? FSE synthetic evaluation. What is FSE synthetic evaluation? So FSE synthetic evaluation is based on I think if some FSE synthetic evaluation is based on fuzzy logic. And today what I'm going to do is that I will use some of the papers I've published and then some of the papers some other people have published so that it will be easier for all of us to understand it. Yeah, I don't want something too abstract. Something that will make the whole thing look like an abstract thing, but it's difficult to understand. Yeah, so what is fuzzy synthetic evaluation? It's based on a fuzzy logic. And what is fuzzy logic? So if you do a little bit of a Google search, just search your Google, and when you do a little bit of a Google search, you come across what we call, you get to know the fuzzy logic. And the fuzzy logic is explained as a form of many value logic in which the true value of a variable may be considered between 0 and 1. This is against traditional information knowledge that we know that if you want to know the truth about something, if you ask somebody a question, an example, are you a male or a female? Normally the response will be that it's either the person will tell you, yes, I'm a male or not. Otherwise, the person will respond by agreeing, will agree with you, or the person will disagree with you. It's a kind of yes or no answer. That's what we know. But according to the fuzzy logic, proof can be seen as something which will fall within a spectrum. And the spectrum here, we look at this from 0 to 1. So the truth cannot just be a binary or just a two response or two outcome of asking a question where somebody will answer, yeah, yes, I am this, or no, I am that. In other words, like what we normally do in our schools, where we do true or false, right? I hope you do true or false. Maybe do you own a Tesla? Emmanuel, do you have a Tesla? And then you say, oh yes, I have a Tesla. Or I don't have a Tesla. Yeah, but according to the fuzzy logic, somebody can respond that or can give a response which will fall between a yes and no. In other words, somebody can give what we call a partial proof or partial falsehood. And this partial truth or falsehood can normally falls between 0 and 1. So for example, I may say that I somehow own a Tesla car somehow. So this will bring us to the measuring scale, which I think already I've made a lot of you to do to come up with your questionnaire, where I have told you to put the questionnaire statement on a Likert scale, and the Likert scale already have mentioned to you to put them in your questionnaire is a Likert scale of 1 to 5, where 1 is considered as strongly disagree, and then 5 is strongly agree. But it's possible that you can also extend this Likert scale. Instead of 1 to 5, you can make it 1 to 7 or 1 to 9. It's also acceptable. Okay, good. So based on this spectrum of truth or falsehood, you can say that somebody is somehow this or somehow that. So it's based on a partial truth. It's not based on just this binary thing, this just true response, this true straight response of yes or no. Okay, so that's what the fuzzy logic is all about, and it is good because this helps us in making decision, because not every decision that you make that is always true or false. It's possible that the decision that you are making will fall somewhere in between. It could be that somebody is somehow happy or somehow disappointed, somehow, or the person can even be neutral. You get my point. So that is how the fuzzy logic works. That's the basic explanation. But if you really want to go into that, you can read more about that. And the person who came up with this idea, and maybe later on you can read about him, he's called Lofty Zadie. Lofty Zadie was an MIT, Massachusetts Institute of Technology. I guess many of you have heard that school, very popular school. Yeah, he was one of the mathematicians there, a computer scientist, electrical engineer, an artificial intelligence researcher, a professor. So you can see the guy had he had a number of portfolios, or he held a number of positions. Is somebody trying to join? Okay. So Emmanuel, if somebody is trying to join, I think you can help me by admitting the person into the meeting or something.
Okay, though.
Yeah, so multiple people want to join, really. Yeah, sorry. Yeah, so please, you can read more about this man. He is the brain behind the modern day fuzzy theory. Fuzzy theory has so many branches. So many branches. For the sake of time and for the sake of our work, I don't think we'll be able to go into all the other branches. We are just taking an aspect of the fuzzy logic theory. We are just looking at the fuzzy synthetic evaluation. It's just an aspect. But if you want to read more and go into this, just get a book written by this man, and you get to know more about this whole fuzzy thing. Okay, good. So now let's go into how we apply this. So how are you going to apply this to your work? Okay, so the first thing, which I've already made you all to do, is that you have to come up with a questionnaire. Okay, so already the questionnaire has already been put together. I won't bother you with going into the questionnaire. And you have come up with your variables or the statements. I just want to open something. So you have your questionnaire, you have put together your statement and all of that. So I guess everybody has done it. Is there anybody here who has not put together your question? If you have not done that, I think you can do that later on. And if you want to know how to put together a questionnaire, I would suggest you visit my YouTube channel. I've put together a video which will assist you in order to come up with a questionnaire. And even when you put together a questionnaire, you can decide to put it into the Google Forms. And based on the Google Forms, you can generate a link. And that link, you can share it with a number of people and they will respond. So let's assume that you have done all these things and then you have received some responses. So what do you do next? The next thing that you have to do is now you have to come to the analysis. You have to come to the analysis. So the first thing that I will encourage you to do is that you have to do some statistical analysis. Okay, I just want to use one of the papers I've published recently to help you because I'm not going to use everything. I've done so many papers on this, so I'm just going to use one of them, a recent paper which I published. Okay, so this is what you have to do. So the first thing that you have to do is do some form of analysis. How do you go about it? So the analysis, first compute the mean. Okay, compute the mean. One good thing is that there are two ways by which you can compute the mean. I just wanted to show you. Can you see my screen? In case you can't see anything, you let me know. So let's assume this is the data or the data that you have. Okay, and the BRI here that you see are the statements, the statement that you put into the questionnaire. Okay, so the various statements. So some of you, I told you that you have to come up with about 10 statements, 20 statements, 25 statements, 35 statements, 45 statements. So all the statements. And then the responses that you get from them. So here I have how many responses? I have 133 responses. Okay, 133 responses on how many variables? 24 variables of 24 statements that I put into my questionnaire. So here, the first thing I will encourage you to do is try to find the mean. The mean. How do you get a mean? Very simple. You can find the mean from the Excel sheet, and from the Excel sheet you just type the equal sign, and then you bring in average. Based on average, just a minute. So you can decide to bring in average. All these things are on my channel. Yeah. So I will not take too much time so that we can somehow save time. So average, and then the average you just highlight or you just copy everything, all the 133 responses, and then you get your mean. Okay, so average, you bring in the average, and then you highlight everything, all the responses under that statement or that variable, and then when you click on, or when you press on the equal sign, you get and enter sign, you get the average. You can then, hello, yes, is somebody asking a question? You can now extend this to all the other variables, and that will give you the mean. Another way by which you can do this is you can do this in the SPSS. Okay, once you have the SPSS, there's no need for you to worry yourself doing all these things. Okay, so I'm going to do that with the SPSS so that we can save time. Then, what other statistic computation did I do? I computed, or I calculated the standard deviation. The SPSS can also give you the maximum and then the minimum values. The SPSS will give you the median. The SPSS can give you the mode. You can also get all these things just from here because the Excel has functions that can help you to compute all these things I've mentioned: maximum value, minimum value, the mode, the median, and all that. Once you have all these things done, then you go ahead and then arrange or rearrange the median and the mean. So if you are going to rank your variables based on the mean, then the highest mean will be the first. Then it will just continue like that till you come to the least among the means. So as we can see here, the factor called Sound Building Policies for Green Finance was ranked as the highest one, right? Because that was the factor that generated the highest mean. But you need to explain why you are using mean, because I've had instances where one examiner has asked me, why are you using mean as a measure of ranking your variables? So you need to explain why you are using the mean. It's important. And then you also need to explain why standard deviation is here. So you are saying you are ranking mean, so why is standard deviation here? Okay, so in my case, for example, the reason why I brought the standard deviation is that there are situations where some of the means are the same. Like you may run the variables and then you will get, let's assume the first variable and then the second variable, they have the same mean of 4.613, 4.613. In that case, what do you do? So if you want to rank the one which is higher between the two, then you have to consider the standard deviation. So the two of them, you now consider the two of them, the one with the higher standard deviation. So in case maybe you didn't get it, let me say it once again. So let's assume you have two variables, and these are the names of the variables, and they all have the same mean. So you are getting the same mean for the two. Now you look beyond the two means, and then now you consider the standard deviation. The standard dev. So the one with the higher standard deviation will be ranked first. So can you see that? Even though the two of them have the same meaning, but the one with the higher standard deviation is being ranked higher.
Please, I have a question.
Yeah, you can ask. Yeah.
So, if the mean and then if the means are the same, does it not mean that like such variables, the responses are the same? So why is that the standard deviation is changing?
There are a number of reasons. Two things. It could be that maybe when you or when you ran off, when you did a runoff, because here you can see that I have run them off to two decimal places, right? Now let me go back to the means I ran. You can see that the means here, they have decimal places of 1, 2, 3, 4, 5, 6, 7. So it's possible that when you run them off to two decimal places, they may end up having the same mean. I hope you get me now. It's possible. So it's possible that maybe the original value of this mean may be, let's say 4.558, and this one is maybe 4.562, and then you run them off and now you have 4.56. And then this one is also going to be 4.56 to 2 decimal places. So now they are the same. So at this point, when you are deciding, then you have to look beyond the two means and then look at the standard deviation. Yeah. And then also another thing is that it's also possible that even though they have the same means, but the way statistics and or the way sometimes some of these variables work, they work in such a way that the differences in terms of the individual responses may differ. Yes, they have the same mean, but the responses, how each of the respondents have responded to the same statement may differ. One may say 1, another person may respond 4, another person may respond 5, another person may respond 2, another person may respond 3. So when you put them together, it's possible they may not be the same, or they will not be the same. Yeah, so that's the reason why. So these are the two possible reasons. Is that okay?
Yeah, it's okay. Thank you.
You're welcome. Okay, good. So now you have your means, you have your standard deviations, you have done the ranking, and what next? So the next thing to do is that you can decide to also run other variables, but these ones, they are not that important. They are not compulsory for you to run them. Shapiro-Wilk test and Kruskal-Wallis test. The only reason why it is important to run Shapiro-Wilk test and Kruskal-Wallis test is a situation where, I mean, you are dealing with respondents from different groups. Yeah, so for example, if you are looking at project managers, instead of the responses coming from the project managers, you also considered architects, you also consider other groups, the QS and then the site managers and all that. In that case, it will be good. Once again, it's not compulsory that you have to do that. Yeah, because when you are trying to test the differences in the responses of these groups, you want to know how the project managers see these variables against how the QS also see these variables, against how the site managers. So if you want to do that, that's great. Also, when you are trying to look at countries, like you collected the data from different countries and you are having about 1,000 or 500 or 200 respondents from Ghana, 500 or 300 from Nigeria, 200 or 400 from Australia, 300 or 400 from Hong Kong, and all that, and you want to test the groups, it will be great to do some of these things, to consider some of the Kruskal-Wallis tests. So what is Kruskal-Wallis test? The Kruskal-Wallis test is just the same as the one-way ANOVA. The one-way ANOVA, and the one-way ANOVA is used to test 2 or more groups. When you are testing 2 or more groups, the differences in 2 or more groups, analysis of variances of groups, what they think about whatever you are considering in your work, 2 or more. Whilst the one-way ANOVA test is more parametric, the Kruskal-Wallis test is non-parametric. What is the meaning of this? And how do we know whether a data set is parametric or non-parametric? Okay, once again, I did a recent video, 2 videos on my page, on my YouTube channel. You can check parametric and non-parametric. You get to know what is a parametric. So a parametric data set will be determined if you run what we call the normality test. What is the normality test? Normality test is that you are just trying to check whether your data set meets the bell shape of data distribution. Okay, so this is a bell shape. And I think many of you have seen or have come across this. So when your data set is normally distributed, it will look like a bell. But if your data set is not normally distributed, it will be skewed. Okay, anytime your data set is not normally distributed, you will see that the when you run it, you see that the data set is that skewed to the left or to the right. And then you can also determine this through the kurtosis and all that. Yeah. So if you run your data set and then you come to a point where you get to know that your data set is not normally distributed, that means the data set has violated the normal distribution assumptions. One is not bell-shaped. It doesn't meet all the other normally distributed assumptions. Then you have to run a different crop or different group of tests or analysis of your data set against a situation where your data set is normally distributed. So for example, if you want to test 2 or more groups, like you want to test project managers, architects, QS groups, the differences and what they think about whatever you are working on, and you are looking at 2 or more groups, then it will be good you go in for what we call ANOVA, one-way ANOVA, if it is parametric. But if it is non-parametric, you use what we call Kruskal-Wallis. So it's the opposite. Okay, you use what we call the Kruskal-Wallis test. Can you see my screen? Is my screen okay?
Yes, we can see it.
Okay, so when your data set is non-parametric against parametric, so non-parametric, if it is two groups or more, and it is non-parametric, that means non-parametric means they go against the normal distribution assumptions. Then you use what we call the Kruskal-Wallis. But if it's parametric, you use the normal one-way ANOVA. Okay, if you are dealing with a one sample, there's one that you have to use. In fact, they are all I've explained all that in my video. Let me quickly show you because there's yeah, but once again, as I said, you don't really need these things. It depends on what you are running. It's not compulsory that you have to run these things. Yeah, it depends on. Okay, so this is what I just mentioned. Yeah, so if it's a 2 or more independent groups, you just use a one-way, and if it's non-parametric, you use a Kruskal-Wallis. If it is you are testing only 2 groups, if your test is 2 groups, like you are testing males against females, and the data set meets the normal distribution assumptions, which is parametric, then what you have to conduct is the independent t-test, which we normally call the student t-test. But if it's non-parametric, we use what we call the man-Whitney U-test. If it's just a one sample, then you use the one sample t-test and the rest. Please, you can go through this. I have started putting these videos together. I think I will start putting them out from Monday. God willing, from Monday I'll start putting video because I've put together videos on each of them. The one sample, 2 groups, 2 or more, 2 paired conditions, and all that. And so I have videos on them. I'll put them out. Okay, good. So that is the reason why I added this, because here I wanted to test the differences. Here is a case where I was looking at data from developing and developed countries, because the study was a global study, and some of the respondents reside in developed countries and some of the respondents reside in developing countries. So I wanted to know the differences. And then also, I also tested the differences in the respondents, like in terms of their job positions, whether they are PMs or they are financial managers, they are project financiers, or whatever. I tested that, and that is how come I put the Kruska Wallis here, the results from that. Okay, any question? All good? So these are the things that you have to do. But once again, please, you can do more than what I'm showing you here. You can show more. You can show more. You can show the mode. You can show median. You can show the range, and so many other tests, depending on whatever you want to put here. And each of the things that you put in your table, you must be able to explain. Don't just put things in your table and just leave them there just like that. No. If you do that, you are going to have issues. The reviewers are going to bombard you with a lot of questions. So it is good that whatever you put into the table, you explain. So if you put in the table like mean, you have to explain the mean. Why standard deviation in this table? Why rank? Why Shapiro work test? Why Kruska-Wallis? Why this? Why that? Explain all that. Okay, I think that's okay. Okay, so I'm done with the initial analysis. The next thing to do is to conduct my factor analysis. Okay, yeah, so to conduct my factor analysis, the question that somebody will ask is, why factor analysis? So the reason why the factor analysis was conducted was to help to determine the factor groupings. Okay, so for example, if you take this data set, I have 24 variables. These 24 variables, I want to know the groups that they will come under. The variable attachments, I want to know where they will belong. So I have 24 variables. Where are they going to belong? So two things. Either you have already determined where they belong from literature. And if you have already done that, then you go ahead and conduct what we call confirmatory factor analysis. Confirmatory. in a way, it's kind of, it has the name connote, kind of, but it's actually, that's not the meaning, but kind of. It means that you just want to confirm what you have established from literature. And when I say what you have confirmed in literature, I conducted a study in 2020 when I started my PhD, where I determined the various factor groupings. That's 2021. Yes, the paper was published in 2021. And in this paper, just a minute, I just want to show you something. And then we go ahead to look at the factor analysis. So please, we have finished the first part. If in case you have a question, as I said, as we are going on, you ask me, then we do it. I'll come back to explain things to you. So I conducted a study in 2021, which was published in 2021. And in this study, the study's title was A Holistic Review of Research Studies on Financial Risk Management in Public-Private Partnership Projects. In this paper, I was able to categorize 54 financial risk into 4. I guess, to 4 or 5 or so. Yes, so that's it. So I was able to categorize the 54 financial risk based on literature, based on similarities of these financial risks. I was able to determine that they belonged to 4 groups rather, not even 5, it's 4. 4 groups. I was able to group them into 4. And the first group of financial risk from the 54, I call them the pre-construction financial risk of PPP project. The second group, I gave it a name, construction. That's the actual construction stage. And then the next group was the operation and maintenance stage of the project. And then the last group was called the disposal and decommissioning. So with this, I can easily go ahead and conduct what we call the confirmatory factor analysis. Why? Because with this, I've already established where these financial risks belong. So it's easy for me to conduct a confirmatory factor analysis from this. Confirmatory. Maybe one of these days I'll do a video on that. But actually, confirmatory factor analysis is an aspect of what we call the structural equation modeling. It's one of the models in structural equation modeling. And that part of structural equation modeling is called the measurement assessment, or the measurement model of the structural equation modeling, which I'll put together a video on it one day. Okay, so yeah, so with this, that I have my groups. But when it comes to this, which is the 54, I have not grouped them into anything. I don't even know where they belong. I don't know whether they are the same or they belong to whatever. I don't know. So with this, the best thing for me to do is to conduct what we call the the exploratory factor analysis, which is a EFA. The EFA. With the EFA, I will be able to determine the groups automatically. And this automatic determination of the groups is based on the software. The software is the SPSS software that is going to do this for me. I will not do this. I'm not going to do this based on an already established groups from literature. So it's called exploratory factor analysis. And if you want to read more about that, once again, I have a video on this on my YouTube channel. So I'm going to conduct one quickly. Actually, that's not what we are going to base on for the analysis, but it's just something to assist you. So just.
I have a question.
Yeah, you can ask, please. Go ahead.
Please, the factor analysis, the exploratory factor analysis.
Okay.
You made mention that the paper that you showed us, you said you conducted a literature. Please, can you hear me?
Yes, come on. Yeah, go ahead.
You said you conducted the exploratory factor analysis that you showed us. You said you conducted a literature review that helped you to do the groupings. And I want to find out, can you do the exploratory factor analysis without considering, maybe without doing the actual analysis in the SPSS, but then you use the literature to do the factor analysis?
Yes, you can do that. And that is what I mentioned, that is that if you are going by that approach, then you are going the way of confirmatory factor analysis. I don't know whether that's what you wanted to know. Is that okay? Have I been able to... Oh, okay. You have not heard of the confirmatory. Okay. The confirmatory is also popular. And okay, it's kind of the nature of our analysis today. I will not be able to do. I think I will not be able to do everything because of the nature. Because there are so many things that should go into this. And if I'm going to do that, that means I have to now start teaching you structural equation modeling, which I think that's not the purpose of this meeting. That will be another. I'll do that another day where I'll do that. So, but in summary, I have done a bit of the structural equation modeling. So if you can see, or if you can see my screen, this is an example of a confirmatory factor analysis, where you use the structural equation modeling to determine whether the factors that you have put into a group, whether they fit into that group or they don't fit into that group. And you were able to determine these groups based on literature. Just like the example I showed to you, where after I identified 54 financial risk from literature, what I did was that I grouped the 54 financial risk into 4 groups based on their common features, common characteristics. So here I determined, based on my literature review, based on what I read and based on the similarities that I saw concerning these factors, I grouped them into 4. Another person may go through the same thing and may group them into 5 or 10 or whatever. But here it's based on literature. It is not based on any software. So it's called confirmatory factor analysis. So you go ahead to now test. Now you have put them into the groups. The question is, do they really fit into this group? To confirm that, you conduct the measurement assessment, which I said is part of the structural equation modeling, which actually is not one of our destinies to do today. Okay, so you confirm that, okay, now you have grouped these risk factors into 4. The question is, do these risk factors that you have put into the group, do they fit into them, or they don't? And I wish I can do that, but I think you have to forgive me for this. Because if I'm going to do that, it's also going to take another, it's a whole lecture on its own. So this, if you want to watch this, you can also come back to my channel. I have a video. I did a recent webinar with some Chinese students. So it's here. You can see that the structure, the PLS. So if you get time, please just watch these 2 videos. Within this, I've explained the confirmatory factor analysis. Yeah, but as I said, it's not part of our discussion today, so I don't want to go to that area. It will take a whole lot of time, because these 2 videos are almost like 3 hours or almost 4 hours. I took some Chinese students recently through that. I did a webinar with them where I taught them the structural equation modeling. And within that, one of the things I discussed with them was the confirmatory factor analysis. Okay, so let's come back. I get Ima, you are the one who asked this question, right? Is it Ima who asked the question? Oh, okay, yeah. Are you okay?
Yeah, I'm okay. Thank you.
You are welcome. Okay, so we have our factor analysis. So once again, what I want to say, and based on the question that you might ask, there are 2 types of factor analysis. Factor analysis, the name connotes, you are just trying to analyze factors. There are 2 types. We have what we call the exploratory factor analysis, and then we have the confirmatory. So it's a exploratory factor analysis where you don't have to predetermine the groups. But what is going to happen is that there is a software called SPSS. SPSS software. This software will help you to determine the groups automatically. Okay, so I'm going to just conduct one. Yeah, it's opening. I just want to conduct one quickly to help you to understand what this is about. And I guess some of you have SPSS. So if you don't have SPSS, try as much as possible to get SPSS. It will be great. You have SPSS. Okay. So this SPSS software will help you to determine these factors automatically. You don't have to predetermine it. It's not like confirmatory factor analysis where you have already predetermined the groups and you are trying to confirm that indeed the factors are in those groups or not. So okay. There's something now. Okay. Just give me a minute. This opening. Yeah. So I have something like this. Please, can you see my screen? If you can see my screen,
Yes, I
just say, okay, great. So let's assume I have this, and they are the factors that I put on. I think they are the ones, right? Okay, if not the one, I can just copy that. Good. So I'm going to copy these 24 variables and their responses. I'm going to paste them in the SPSS and then run. Okay, so I have my 24 variables. And I'm going to just do the analysis. So you click on Analyze. You go to Dimension Reduction. And then you click on Factor. And then you just copy all the factors. Let me go. One. You have to say, yeah. Oh, five. Yes. Yeah. 8. Okay, so I have all my I have all my variables, so now I can just
It's
run
still in
them.
string. Data type is still in string.
Uh, just a minute. Let me check. Oh, sorry. Yeah, I have to change all of them. Anyway, another way by which you can do this without wasting time doing all these things, you can just import. And then you just
Please changing it from the string to the numeric. It's not going to delete the figures in the overview.
the overview. No, I just want to change them from the string to the numerical values, and then it's the scale that you have to be more concerned. But this is numerical, so I have to change them to scale. Yeah, either ordinal or scale. That's the most important thing. The nominal is more like maybe age. That scale or ordinal. The best thing to do this is just to import. Okay, import them using the either using Excel or CSV, any of them. I think there's something wrong. Okay, this is still string. Okay, yeah, so let's check. Yeah, I think that everything is fine now. We can go ahead. So you click on analyze, you come to dimension reduction, and within that you see the factors. You can copy all that, put them here. So you just put them to the other side. Then you look at the descriptives. What do you want to show? You want to see the descriptions like the mean, the mode, the standard deviation, and all that. And then you check all these ones out. Come to the extraction. Want to see the scree plot, and then the eigenvalues we are maintaining this at 1. Normally these are default; they're already there. You don't have to work on them unless you want to change the threshold
What's the
or
purpose
the.
of the eigenvalues?
It just to help you to know the the factors or the threshold or the point at which the groups that can be determined to be important as part of the factor analysis, because normally the software would generate a number of groups for you. So we are saying, or the threshold is saying that if you get an eigenvalue which is more than 1, then that group is considered to be important. But if it is less than 1, then we take it out. The same thing as when it comes to the factor loadings, where the threshold is 0.7 and above. But once again, you can also decide to lower the standard to maybe 0.5 or 0.4 or 0.3. But if you do any of these things, you have to give us explanations. Then we have the rotation. We have different types of rotation, but the one which is very popular. So once again, here too, you have to explain any of the options that you pick when you are running the SPSS. You have to back it with good explanation. The common and the most popular, or the popular one that most people use in our field of studies, the Verimax. So you choose a Verimax, and then you click on continue. In terms of the score and the rest, we don't really need them. Then you click OK. Once you click OK, you get a resource. And within the results, we have the descriptives in terms of the mean, standard deviation, and the analysis. So here, instead of going to compute the mean, standard deviation, and all that, you can get them from the factor analysis, which will support your initial descriptive analysis. But instead of computing all that, you can do that from the factor analysis. And then from here, you can also, or we can also see the number of groups. So here, based on the eigenvalue of 1 and above, we are seeing 10 groups. 10 groups. So out of the factor loadings, we are getting 10 groups. I mean, based on the eigenvalue. And these 10 groups can also be seen on a screen group.
The 10 groups, where is it?
Yeah, the 10 groups are here. So normally you see the total variance explained. That table, within that table, it will give you a certain amount, which is the cumulative variance explained, the total value, to get to a point where it will just end to stop. So where it will stop is considered as where the groups is. So here it ends at 10, but sometimes it can end at 5. It can also end at 15 or whatever, depending on the number of groups that you are looking at. So here, the total variance explained is 61.365%, which can be seen on which can be seen at the 10th component. And the 10th component also has an eigenvalue of 1.039. The rest, the other groups, which is from group 11 to group 24, they have eigenvalues less than 1. Less than 1. You can see that. Okay. And if you want to confirm this, you can use the scree plot. Within the scree plot, just look at where the 1 threshold is, which is the eigenvalue is 1. So on above the 1, count the groups. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So above 1. And the rest are down there, which are not important. Good. So apart from the total variance explained table, you can use the scree plot to confirm. Okay, so the dots which are above 1 on this curve, they are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Now let's come to the groups, the groupings. Okay, so here, it seems we couldn't generate any group because of the nature of the data set. So if you conduct your SPSS and you are not able to generate any group, then it means it's possible there is a problem with your data set. You have to go back and check your data set. So here, yeah, I guess there is a problem with the table, but we were supposed to get, because we didn't get any rotated component matrix, it's failed. That means there is a challenge, there is a problem with the data set. But if everything is okay, let me use the other data set and see whether that will work. If everything is okay, you are supposed to get some groupings from your SPSS. So let me use let me use this. Let me try this. So I have another data set here. Try and see whether this will work. To work, that's great. It's not. So anytime you run the factor analysis and you don't get what you are expecting, please go back and check. Okay, I didn't also talk about the component. In terms of getting the factor group, there are a number of measures or features that will help you to get groups, but the common one that we use, the principal component, which is the PC, principal component, which, yeah, so, and then the Verimax. Let's try and see whether this one will work.
I have a question.
Yeah, you can ask. Go ahead.
So you did the analysis, and then you saw the groupings from the plot.
Great.
And then you went to check the rotation, and then you said it failed.
Yeah.
So,
but this one has worked. Okay, yeah, go ahead. Yeah. So
how will I, how will I know that the thing has failed? Because if I'm having the groupings, why don't I go and check the strength and then start to put them into that?
How do you know that your analysis has failed? Is that the question?
Yes, please. Because I'm seeing that the purpose of it is to put the variables, and now I've seen the variables from 1 to 10. 10 groupings. So why don't I proceed and then for me to say that the thing has failed? I don't know why.
No, you are okay. I get your point. I get your point. Yeah, I get you. Yes, the groups are there, but the question then is, yes, you have seen the groups, but the question then is, which variable will go into which group? That's where the whole thing is. Which variable? Yes, we can see that the groups are 10. Excellent, very good. But the next question is, which variable will go into which group? And that is where the issue is. The SPSS is supposed to help you to know the variables that will go into the variables that will go into each of the 10 groups. And the issue is we don't have that. The SPSS or the software couldn't help us to determine that. That is the reason why I said we have failed. But let's check this one. With this one, where I use 20 variables, here we are seeing how many groups. There are 6. Can you see that? There are 6. And the total variance explained is 75.92%. And we are having 6 groups. Okay, so with the 6 groups, we look at the rotated component matrix based on the Verimax, and the 6 are here. And here you can see that the factors have been put into groups. In a way, we can see that the factors have been put into groups. But for us to know which group each variable belongs to, what we have to do is that we'll pick the variable and put that variable into a group that variable has the highest factor loading. So for example, if we pick the B1, factor B1, among all the factor loadings that are coming out in each of the 6 groups, we can see that it will fit well in group 4, because it's group 4 that it is recording the highest factor loading of 0.796. If we pick B2, in B2, the highest can also be seen in group 4, because it's within group 4 or under component 4 that is recording the highest factor loading of 0.836, and so forth and all that. So for us to, not to waste too much time, we can do this manually. This is when you are doing it manually, but the SPSS software has a way of helping you to determine this easily without doing this one by one. So you can sort them out. So how do you sort them out? So you can say that sorted, you suppress any variable which is you can determine, but the original threshold, recommended threshold, is supposed to be 0.7. 0.7. But if you check your variables, you can lower this standard to 0.5 or 0.4. But anytime you lower the standard from the agreed standard in literature of 0.5 to, let's say, 0.6 or 0.5, please, you have to argue for that. You must be able to argue. Yeah, ask.
Please, I want to find
Please
out.
go ahead.
Is there any way that a variable, when we are doing the analysis and you realize that a variable doesn't form part of any
A variable will not be part of any group. Yes, it is possible.
Yeah.
And it's possible we'll see that very soon. So for example, if we decide to leave the threshold at 0.7, let's see what will happen. Let's run that and see. So 0.7, I click on OK, and I go back to the resource. So I just want to. Let me run it again. It seems there was a little bit of an issue. Again. Okay, so let's assume you have this. What can we see? Let me suppress it. To the 0.7. If I suppress this to 0.7 and I have OK, what we can see from here is that some of the variables will automatically go away. Can you see that? Ima, the question that you asked. So some of the, yeah. Is somebody, okay, Fred. Has Fred been able to join? Fred, are you okay? I think I can see that Fred is asking that he should be, somebody should admit him. Let me check whether, sorry, just a minute. Oh, sorry. So many people are waiting. Sorry about that. Okay, yeah. So Ima, we can see from here is that some of the variables will automatically go away. And here you are supposed to drop them. The ones that didn't meet the threshold should be dropped from your analysis. So here we are going to drop B20, B6, B15, B7, B11, B4, B3. Why? Because they didn't meet the threshold of 0.7. But this is why I mentioned that you have to lower you have to lower your standard, and it's acceptable. Other than that, you lose so many of your variables. So I'm going to lower the standard a bit and make it 0.5. Okay, and here you have to explain why you are lowering the 10 to 0.5, and it's acceptable. It's something that is acceptable. You can do it, and many studies have produced results using factor loadings of 0.5 and above. It's acceptable. So please explain, because the common threshold, according to Joseph Hare Jr., Christian Rengel, and all the popular scholars in this area, is that when you run your SPSS, the factor loading should be 0.7 and above. So anything less than 0.7 and above is not acceptable. But other studies have also argued that you can lower your factor loadings to 0. Even 0. I have seen 0.3 and 0.4. But if you are going to do that, please, you have to look for a literature, a paper that somebody has published, and use that as your backing vocalist. Some people will say backing vocalist. That's something that will support you. Other than that, anybody who will read your paper will throw your paper away and say that you have conducted a study which is not statistically strong enough. So here, if I lower the standard to 0.5, you can see that I've been able to retain so many variables. And you can see from here that the groups are clear, and the members of each of the groups are also clear. So here we can see that in group 1, the statistics or the software has been able to. Yeah, please go ahead.
B10. B10. The value there is negative.
Yeah, you have to take it away. Yes, I will argue that you have to take it away. Whilst others have also have reasons why they will retain them and explain, but in general, I will encourage you to take it away. Yeah, it's just trying to say that two things, normally two reasons why some of these things happen. One of them is that is the way you put together the variable, like the way you put a statement. For example, instead of saying you are going forward, you decided to say you are going backwards. When I read some study, that's what they said, that it's possible that you may get a negative factor loading as a result of the way you framed, you designed, you put together the statement. That's why you get this results. Yeah, but normally if you get a negative response, I will encourage you to take it out. Yeah, so for example, now we have our 6 groups. Beautiful. And this is what you are going to use. Okay, good. Another question that somebody may also ask is, why is it that B6 has two factor loadings? Which one do we choose? Okay, so for B6, we have 0.607 and 558. So you choose the factor loading which is higher among the two. So here we will put B6 under group 1, not group 3. Great. So now we have all our groups. So what next? So the next is where the fuzzy synthetic evaluation will come in. So now we have our groups. So I'm going to take you back to my resource. So good. So an example, what I did, the data that I used, that data was very good data set. And when I ran the SPSS, this is the results that I got. Can you see that? So similar to what you can see. So what do you have to report? 1, report the factor loadings. Where do you see these factor loadings? That's what I've just shown, the rotated component factor loadings. Just report them. And then another thing I will encourage you to report, which most studies have done, is to report the eigenvalues. The eigenvalue. The question is, where do you see the eigenvalues? So when you check the results of the SPSS, check the total variance explained or total variance table, this table, the total variance explained table, you see the eigenvalues. So they are here. Okay. You can either use a percentage or you can use a raw score. Any of them is acceptable. You can use a raw score or you can use their percentages. Any of them that you present is okay. What other thing do you have to present? The other thing that you have to present is the total variance explained. So the total variance explained is also here. I will encourage you to use the rotation sum of squares loadings. Okay, so they are here in terms of the percentages. You can see them here. And then what is the cumulative total variance explained? The cumulative is just about adding. So this one is the same. When you get to the second one, you add this to the second one, then you get the cumulative of this. The third one, you pick the 56 and you add it to the total variance of the third one, then you get that. So let me just, please, can you see that? So you add the total previous to the current total variance explained, and that will give you the current cumulative total variance explained, and so forth and so forth. Is that okay? Any question with this? All good? Great. So you add all of that, so you get to the final, and the final should be this. You can also pick this straight away from here. The SPSS software has also done the additions for you. So this plus this will give you this, 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 this plus this will give you that. Okay, yeah, so this is what you have to report. You can also have your own way of reporting this, because I've seen studies where people report these things differently. Whatever you want to report it, that's fantastic. So now we know the groups, and now we have also been able to determine the mean, and we have ranked them. So what is the next step? The next step is to now conduct the actual fuzzy synthetic evaluation. Okay, but don't forget, all these initial computations are parts of the fuzzy, and we'll see the reason, the reasons why these initial computations are important. Now let's come to the next part, the next section, which I have determined it as determining the weightings of each of the variables in each of the groups. So already we have determined the groups through the factor analysis, and we know where each of the variables belong. Now we want to know the weightings. The weightings here refers to the percentage of contribution of each of the variables to the group. The percentage of contribution. Okay, so currently, as we are on this teams, I think we have about 10 or so people here. So if we want to know the percentage that each person is contributing to this discussion or today's meeting, I can easily assign some scores to them. But here, in order to not to worry ourselves with assigning scores, we can go back to the means that we computed. We are going to use the means. Okay, we are going to use the means. So what are the means? Already we have determined the means in our previous analysis. So we will pick each of the means and just bring them here. So when we pick group one, or when I pick group one, the factor DF6 or DGF6 has a mean of 3.687, and this is from here. It's just from here. DF6 here. The mean that we have already determined. We just pick them and come and put them here. So we pick all the means. We just come and pick them. You look at the mean for the DF23. You put it there, 12 and all that. Then after we have picked all the means from the previous analysis, you sum them. You sum the means together. So here I had 1, 2, 3, 4, 5, 6, 7. I have 7 variables in the first group. So all the 7 variables, you sum their means together. And when you sum their means together, it will give you this. Can you see that? Can you see what I'm doing? I've put a cursor on it, the sum. So you sum all the means of each of the variables. And once again, the means are coming from the previous analysis, don't forget. Okay, so you pick each of the means, you put them here, and then you sum all of them together. The total will give you 24.127. Now we look at the percentage. And the percentage here, I mean, or the contribution, the ratio, percentage, whatever you want to call it, their contribution. And the contribution is, if we pick a mean of 3.687, which is related to DF6, what is this mean percentage with respect to the total 24 of all the 7 groups? Okay, in other words, it's just like you pick 3.6 7 divided by all the other means, which is the total is 24.127. 24.127. These, are you okay with this? Any question on this? Are you all okay? Great. So you do the same for each of them. So you pick the second variable, the mean of the second variable, and also divide by the same total, the total of the 7. You pick the third, divide by, pick the fourth, divide by, pick, divide, pick, divide. So you can see the weighting or the weight per factor. And when you sum them up, it should give you 1. If you sum them up and it's not up to 1, then it's wrong. Yeah. So if you sum up and the total weighting is not 1, then there's something wrong. So the total weightings or weight of each of the variables, you determine that. You do the same for the second group. So the second group, you sum up the means of all the variables within the second group. You sum them up, and the total will give you 21.234. And then you also determine each of the weightings by taking each of the mean within the second group divided by the total of all the means in that group. Great. So you do the same for all of them. Then you come to the third group, you do the same. So the third group, so you sum up the total of the means. And then from there, you determine the weighting of each of them. You do the same for the fourth group. And then you determine the weightings. You do the same for the last group. Okay, and then you determine the weighting. Okay, good. Now we have done this for the individual variables. Now we want to know the contributions of each of the groups. Here, the next step, we are not looking at it from the individual variables, as variables by variables, but the second step, we want to look at it from the point of, or we want to know this from the groups. Okay, so already we have been able to determine the total mean of each of the groups. So if you pick group 1, the total mean is 24.127, group 2, 21.234, group 3, 19. And all that. So you sum all the mean, the total means of each of the groups together. So 1, 2, 3, 4, 5, you sum them together, and the total will give you a certain figure. With this total, you can also now determine the weighting of each group. How do you do that? So you just pick the total mean of the group divided by the total mean of all the groups. You pick the second one, you do the same. Pick the third one, you do the same. You pick the fourth one, you do the same. Then you pick the fifth one, you do the same from the 79. So now we have determined the weightings. Please, any question on this? So this is the first step. I hope everybody is okay. Okay, good. Now the next step after determining the weightings, the next step is to determine what we call the membership function. The membership function. This is where you need to be a little bit careful. It's not difficult, but you just need to be careful. You just need to be careful. So please, we are using the same groups. The groups will not change. So the factor analysis is very important. The groups will not change. So everything that you have done for the weightings, you have to come and do the same for the membership functions. The groups will not change. Don't change anything from the, at this point, there's nothing that you have to change from the groups. And there's no member, there's no variable in the group that you should take out or remove. Everything is important. Once you establish, you agree 100% that from the factor analysis, from this factor analysis, everything is okay. Please, you don't have to change anything. Okay, so if you are not sure about your factor analysis, please go back and check it again. Because once you determine the groups from the factor analysis, that's it. The subsequent analysis, the subsequent computations, you can't take anything out. Okay, now let's come to the next step, which is the membership function. So once again, I just want to take you back. I want to do something simple. This is a paper that I have just published. So please, if you have not seen this paper, try as much as possible to download it and read. So this is the paper, and this is what I put in. So it's the same thing. And one thing I want to encourage each and everyone is that you have to be able to store your data, and then you have to be able to store your analysis. I don't want to encourage a situation where people, sometimes people do some, excuse my language to say, they use some crude means to generate some results. You ask them how they went about it, they can't even explain. It's not the best. Always have sources, always have some evidence, always have something that you have stored, which you can show to people if they ask you how you went about your work. So here, as you can see, everything I have published is the same thing I have stored in my Excel. This is something that's on my laptop. So it's not something that is like, I'm showing something that is abstract or it's from somewhere. It's something I did. I genuinely did it and I've published it. Yeah, so please do that. And also I want to encourage each and everyone here that make sure you find a way to store your data. Like this data that we are collecting. Once we get a resource, once you get a responses, find a way. The good thing is that nowadays we have something like the Google Drive. Even if your school does not have this cloud storage, you can use Google Drive, store your data for future purposes, so that one day when somebody come and asks you, how did you go about this? Where did you get the data? You will not be scratching your head and be like, oh, I don't know, I just did it. And I mean, because nowadays, like increasingly, people are becoming, people are paying attention to how people went about their studies, how they generated their results and all that. So please, you have to be transparent. You have to find a way to boost your credibility. Very important. Okay, so once you have this, make sure you have finalized the factor analysis. And once you are done with that, the subsequent ones, you can't change anything. So we have just determined the weightings, and I want to show you once again these ratings. These are the weighting functions. Okay, just like how I just showed to you. Now the next thing is to show what we call the membership functions. The membership functions. This looks some way, but it's not that difficult. Okay, let me show you how it did it. Yeah, I mean, when you read the papers, people try to just say put some things which make the thing look complex, difficult. But I try as much as possible to make things so easy. I break them down so that anybody who is reading and anybody who want to follow what I've done will be able to learn. So the next step is determine the membership function. The question is, how did you determine the membership function? Very simple, straight away. Okay, so the membership function, this is where the responses from your data set is very important. The responses from your data set. So I'm going to take some of them for the sake of time. I don't think I will go through all of them, but it's the same. So at the end of the day, it's the same thing. When you go back to your responses, and when I say your responses, I'm talking about your Google Forms. You must be able to tell us the percentage of people who responded to each of the variables. I don't know whether I put them here, I guess, but okay, if I didn't, but it's the same at the end of the day, in a way. Okay, the percentage of people who gave the responses to each of the variables according to your Likert scale. Okay, so this is what I mean. For example, if I pick the first variable in group 1, which is the DF6, the percentage of people who responded or who ticked, when I say respond, I'm talking about ticking. You know, when you go back to the Google Forms and all that, people tick, right? So count the number of people who ticked the first variable under the first Likert scale point. So as you can see from here, you can see that here, 0 people or 0, I got like nobody, in other words, 0, which is nobody, ticked 1. 1 means strongly disagree. Nobody ticked 1 with respect to the least interest charges from the 0 project, which is the first variable. When I come to disagree, which is the first, so the first one is 0%, like nobody. So the percentage is 0%, or if I'm looking at the number, is 0, nobody. The second one is the disagree, which is number 2. Here too, you can see that it's also 0, 0, 0. Why? Because nobody also take this under the same variable. But when I come here, I can see that, okay, so here the total number of, I think it was 182. So I can easily determine. So when I come to neutral, so here too is also 0. But neutral, the total number of people who ticked neutral for least interest charges for net 0 project, which is the first variable under the group 1, 35 people or 35 responses out of the 182. Okay. I wish I can show you another because I have a number of them. So I just want to show you one of them. Just give me a minute. I just want to show you one of them where I have the figures. Here I have computed them, or I've turned them into percentages. So it's kind of difficult to know what exactly I did. I just want to show you one where I have the people there. I just want to I just want to show you the one where I have the people there, like 3 people, 5 people, 6 people, 7 people, 8 people, and all that. Just give me a minute. I just want to open one. I just want to show you.
Is it similar to when you are doing the relative importance index?
Yes. It's also important. Yeah, that is also good. You can use the same approach to go about the relative importance index. Yeah. Okay, good. So this is what I'm talking about. So as you can see from here, okay, as you can see from here, you can see that the number of people who take each of them. I mean, I want you to focus on here, this side, this section. The total number of people who responded to my questionnaire, they were 200 and what? 249, right? So under the 249, if I pick the first variable, you can see that the first variable, nobody strongly disagree. But you can see 7 people who disagree. And then you can see 50 people who neutral. And then you can see 108 people who agree. And then you can see 84 people who strongly agree. Please, can you see that? Can you see? So this is the people, and the total number is 4 something. Good. So you have to just turn these things into percentages. How do you turn these things into percentages? So they're just a decimal, or turn them into percentages the same. How do you turn them into percentages? So when you check here, you just pick the 0 divided by 249. And when you pick the second one, you just pick the 7 divided by the 429. Then when you check here, you have to pick the 50 divided by 249. You pick the next one, you just pick 108 divided by 429. And then when you pick the 84, which is the last one, it's just the 84 divided by 429. Can you see that? So by doing that, by turning the numbers into percentages or decimals, you get what we call the membership function for each of the variables. So this is how you determine the membership functions. Please, is it okay? Oh, this is a little bit difficult because here you have to go back and check your responses. That's why it is important you keep track. You have to check. You have to track each of the responses that you got from your Google form links or link. Or if you use whatever, you have to. So you have to record all these things. Yeah. So you have to go back, check each of them. How many people responded to this? How many people responded to that? How many people responded to the total number? This, that. Check everything. Check. So you can see that all the people who responded, they are here, and the total number of responses are here, 249, each of them. Then you just turn them into decimals, and then you get your membership functions. Okay. Any question on the membership function? If you have a question, you can ask. Okay, good. Now we have the individual membership functions. Now the next question is, how do we determine the membership functions of the groups? Of the groups I'm talking about, if we pick a whole group, what is the membership function for each of the groups? How do you determine that? Very simple. So here we use a matrix. And the matrix here is that you are going to multiply the weightings that we determined. Remember the weightings that we determined. Okay, you multiply the weightings of the individual variables by the membership function of each of the variables. Okay, what I mean is that, I'm just going to show you one. What I mean is that if you pick I know, I mean, some of you or most of you, you have done some form of mathematics. But if you have not done that, you can follow this. So you know matrices and all that. But if you have even not done that, you can follow this. So how do you determine the membership function of each group? So you pick each of the column. So within the group, for example, this group, I have about 7 or 8 variables. So the first column, which is under the strongly disagree, you pick that column and then you multiply by the weightings. And don't forget the weightings, where the weightings are coming from. It's coming from our previous analysis, the weightings of the individual. So you multiply and that will give you this figure. You multiply and add. It's more of like multiplication and addition. You multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, and then to give you that. Then you come to the second column. So in the second column, you also pick the second column and you multiply it also by the same weightings. So you multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, then to give you that. You do the same for the third column. So you pick the third column, then you multiply by the weightings. You multiply, add, multiply, add, multiply, add, multiply, and give you that. Then we come to the fourth. You multiply, add, you multiply, add, multiply, add, multiply, then it will give you that. The fifth column, the same. You multiply, you add, you multiply, you add, you multiply, then you get that. Great. So we have the membership function for group 1. Now we can also do the same thing for group what? Group 2. So let's do group 2. So group 2, you pick the first column, which is under the strongly disagree. Then you multiply by the weightings. And don't forget, once again, the weightings are coming from the previous weighting function analysis. Then you multiply, you add, you multiply, you add, you multiply, you add, you multiply, you add, then you get that. Then you do the same thing for the second. You multiply, you add, you multiply, you add, you multiply, you add, you multiply, then you get that figure. You take the third column, you also multiply, you add, then you give you that. You pick the fourth, fifth, and then you get that. Then you come to the next group, and the next group, so you do the same. Okay, so at the end of the day, you are going to get the membership function of the individual variables, and then you also get a membership function, 5 membership functions for the groups. So you can see here 1, 2, 3, 4, 5. Now let me take you back to the one from my studies, the same thing anyway, the same idea. It's not, yeah. So if you pick this one, for example, you multiply, you add, you multiply, you add, you multiply, you add. Oh, is that the same? Oh, this is different, sorry. Yeah. So, yeah, so you do the same here. It's the same idea anyway. But I think the way I went about it, that's the same. Yeah. So you pick the weightings, and then you multiply by each of the columns. You pick the weightings and you multiply by each of the columns, and to give you the results. Anyway, let me open the other one. We still use that because that one has the figures which are clear, but it's the same. In other words, what I'm trying to say is that I use the same thing, the same idea, the same approach to generate the figures. Okay. Okay. Any question on this? If you have a question, please ask me, because this is a very important aspect of the analysis. Okay, good. So now you have the membership function for each of the groups. Now we can go ahead and determine what we call the criticality index. So let me take you back to my table. So this is a membership function. We show the weightings, we show the membership functions of each of the groups, and then also you show the membership function of so you show the membership function of each of the groups, and now you determine what we call the criticality of each of the groups. How do you determine the criticality of each of the groups? So you pick the membership function of each of the groups, and then you multiply by what we normally termed as the alternative grades. What is an alternative grade? The alternative grade here represents the point on your Likert scale, and the point on your Likert scale is 1 to 5. Great. So you pick each of the membership function, which in this context we will assume, or we will say they are the fuzzy matrix. You multiply by the alternative grade. So 1 times the first column plus 2 times the second column plus 3 times the third column plus 4 times the fourth column, and then 5 times that. So the total will give you a certain figure. Do the same also for the second group. Also all multiplied by 1, 2, 3, 4, and 5. You do the same for the third group. You do the same for that. And you do the same for this. And by doing this, you get to know what we call the critical index for each of the groups. And based on these critical index, now you can rank or rate the group that you can say, or you can establish that it's the most important group, followed by the other ones. Another thing to do is that we have to also determine what we call the overall critical index. How do we determine the overall critical index? To determine the overall critical index, this is what you have to do. Now you have to determine the critical fuzzy matrix. How do you determine the critical fuzzy matrix? So based on the membership function that you determined, you multiply the membership function columns by the group weightings. Now you will not multiply it by the individual weightings, but you multiply by the group weightings. Just a minute. Oh. Okay. If somebody has put a question. Okay. Okay. Welcome. Okay, that's okay. Let me go back. Yeah, so you multiply by the columns by the group weightings. So don't forget this, the group matrix. Sorry, the group membership function. And this was the individual membership function. When I say individual membership function, I'm talking about the membership functions for each of the variables. Yeah, but this is for the group. So for you to get the overall index, you first determine the matrix for the entire group by multiplying the membership function columns of the group membership function by the group weightings. Here is not the individual weightings, but the group weightings. Don't forget the group weightings. Okay, the group not the individual, but the group. So when you multiply that by that, you'll be getting these results. So the second column will give you this. The third column will give you that. The fourth column will give you this. And then the fifth column will give you that. Then what do you do next? The next thing to do is you multiply these results that you get by the alternative grades. This is 1 to 5, based on your Likert scale. So when you do that, you multiply this plus this, and then plus this, plus that will give you the total overall. So the overall critical index is 4.08 something. Okay, now you use that as a benchmark. So based on the 4.08, so the entire data set, the criticality or the critical score out of the entire data set is 4.08. So based on this benchmark, we can say that the second group, the third group, and the fourth and the fifth group, they are more than this. But it doesn't mean, I mean, it's just a matter of just trying to explain. It's just a matter of just trying to determine the ones which are more important than the others. Based on this, based on the 4.08, you can say that from the Likert scale, you can say that the variables presented in this study are important. The reason why they are important is that if you go back and check the 4 from the Likert scale, 4 is considered as agreed. It falls under or within the region of agree, which is which connotes that the respondents agree that all the variables that you have put into this analysis are important. Yes, they all agree, but as to which one is more important than the other, you look at the individual critical scores. So if I'm going to rank this, I will say that the fifth group is the most important factor groups or factor group. And then the next important factor group will be the second. So this is going to be my first, followed by this being my second. Then this will be my third. This is going to be my fourth. And this is probably going to be my fifth. So when you are interpreting, you have to place more emphasis on the one that came first. Which one came first? If I'm going back, so the issue of contract and governance performance measures, according to the respondent, these factors are very important as far as sustainable performance measurements of PPP projects. This was about PPP projects are concerned. That's the most important. These are the most important factors that anybody who wants to track the importance of sustainability performance in their PPP project should be watching. Then this is followed by the second group, which in this context is the financial performance measures. That is what the respondents are saying based on the data analysis or based on the scores. The third group is the environmental performance measures. And then my fourth group is the technical requirement performance measures. The ones that they place as last is social performance measures. So here, you can argue when you are concluding your study that even though social issues are very important, like issues of ensuring accessibility to disabled persons, restoring and preserving cultural heritage and diversity, enhance market opportunities, they are all important, but it seems that studies have not been directed in this direction. So you recommend that in future, when people put together a study or when people are investigating anything concerning performance measures of PPP project, in order to achieve sustainability, they should focus more on social performance. Also, you can also argue that the reason why it seems respondents gave low responses to these variables is that maybe they don't have much understanding of what these social performance measures are. Therefore, you encourage that there should be more education in the construction industry where these social performance measures will be taught or will be explained to the key stakeholders so that they will get. So you see how, so that's how you put together your study. Yeah. Any question? Let me come back to my paper. It's the same idea, as I said, it's the same idea. It's just the way I've arranged the data, because some of them I put them somewhere. That's why I think there's a little bit of confusion, but it's the same. It's the same idea, the same approach, it's the same information. Yeah. Yeah, somebody was saying something. Yeah. What did you say?
Yeah, I have a question.
Please, you can go ahead.
Please, you made mention about everything starts from the factor analysis. Now, the problem is with my side, the problem with me is the naming of the groups.
Okay.
We use that to name the group because if you see some of the variables, you realize that they are not related, but the analysis
they are not related. Yeah.
Yes,
yeah.
but
That's a fantastic. That's a fantastic question. So the question is, how do you name the groups? Is that your question?
Yes.
Hello, Ima. Yeah, so to answer this question, there's a huge debate on this. And that's the reason why sometimes people even argue against exploratory factor analysis. Because the issue is that exploratory factor analysis is a software that will generate these variables for you. It's not something that you put them together, because as I said, if you are going by literature and you are reading, maybe you have done some form of literature review and you extracted these variables, it will be easy for you to just put them under one umbrella, right? It is going to be easy. But here is a case where these variables, you don't even know how come they came together. It's just a software that determines their variances, their total variance explained and all that, and also based on their factor loadings and hygiene values and all that, and they have put them together. So the question is, how are you going to do this in terms of the naming? So here, the truth of the matter is that you are free to give them any name that you want to give. So it's acceptable when it comes. So one thing I want you to understand is that when you conduct exploratory factor analysis and you get these factors, you are free to give them any name in terms of I'm talking about the groups, any name that you like. But when you are giving them the names, these are the things that you have to look at. You have to just study the factors carefully, and then give it a suitable name. Just carefully, and give it a name. And any name that you give to it, when you are explaining, you have to justify why you have given that name, and also I will encourage you that just also explain each of the variables that will come under the groups. Yeah, so you are free to give them a name, but just study the variables in the group carefully, based on your own experiences, based on what you have read from literature, and give it a name. And it should be. And it's the difficulty is that, as Ima asks, sometimes you may get variables that it seems they are not correlated. They don't have anything in common. They are totally different. Maybe somebody is talking about east, another one is talking about west, another one is talking about south, another one is talking about north. Scattered. I mean, Yes, this will happen, but still find a way to give it a name. Find a way. That's what I would say. Find a way to give it a name, and then just explain each of the variables under each of the groups and why you think that that variable fit into that group. So for example, if I give something social performance measures and I'm explaining something like finance, and maybe let's say one of the factors under this is finance or reputation. Well, how does reputation or high user rates have impact on social or has something to do with social performance? So it is up to me when I'm explaining to relate my explanation to the name of the factor group. You have to find a way to explain it. That's per my experience. That's what I will tell you. Yeah, because it's kind of hard, and there is a huge debate as to how to name them and how to go about it. It's kind of difficult because you get factors that are different. Yeah, so please go ahead, give it a name, but when you're explaining, try as much as possible to explain the variables under each of the groups, to relate them to the name that you have given to the group. I think that's the best way to do it. Yeah. On that note, you're welcome. On that note, I think that is all. Once you determine the total variables and the components, and then you show the variables, I think that is all. Yeah. I think that's all. Yeah. Yeah. So that's, and then now you come to the explanation, the discussion. So during your discussion, this is where you have to mention the factor groupings, the index that you got, the ranking, whether it's a first ranked or second ranked based on the critical index. And then you explain why it is important. You explain each of the variables under each of the groups. And once you are done, that's the end of the story. You go ahead to conclude, but sometimes you can start with the implications of the study, and then you go ahead and then conclude. Yeah. Then there was a mistake that is. Yeah, you can ask.
So
Please go ahead.
the factor analysis.
Yeah.
It's like what if maybe I do my videos, you all get different names.
Yeah.
And if I'm trying to compare, maybe I'm doing a discussion and I want to compare it with literature. How am I going to, because maybe what I'm doing doesn't, my name is different from maybe someone who.
From my name. Yeah. Yes, go ahead. Your line is breaking, sorry.
Yeah, so how will I cite that?
Come again, your line, we didn't hear from you well. Can you repeat your question?
Please, can you hear me?
Come again. I didn't get what you said.
Yeah, so my question is, if you are doing the discussion section, the discussion section, you are supposed to
with other studies.
And now the thing is that naming of your variable is different from other people's study. How you cite other people that this is what this person is saying on this particular variable or this particular.
So I get your point. I get what you are saying. That, for example, maybe if you have something like microeconomic factors, and under the macroeconomic factors, you have something like reputation under it, or the user rate, or something which is not related to microeconomic factors. So how are you going to explain this insight? So here, once again, it demands that you have to put in some of your experiences. That's what I would say. And when I say your experiences, based on some of this, based on studies that you have conducted in the past, and based on the literature that you have read, that is what I will encourage you to do. Because one factor which you put, or which will come under the microeconomic factors, another study, we may see the same factor coming under something like risk management. So in that case, what you have to do is that if the same factor, which used to be under microeconomic factors, is now coming under risk management factors, you have to explain and justify it why you think in your study a factor that we all know that normally they come under microeconomic factors now is being put under risk management factors. You have to explain and justify. How do you explain and justify this? It's based on your experience, it's based on this, the studies that you have read, and it's based on the context. Explanations in research articles, especially when it comes to the discussion aspect, is more of a context than what people have done in the past. Because what somebody may say is white under one study, another person may explain the same thing as something which is black under another study. And it's all about context. So the context is very important, Ima. The context, the same factor or the same variables, which maybe we see them to be something like investment factors, may go under another group of factors and may go under another study, and the same factors which came under investment may be explained as technical factors. So please, the context is very important. Context. Let me also give you another context. Let's say you are explaining something which is related to climate change, the factors. Maybe you read a study from India, and that study, they put some factors of climate change under microeconomic factors. Maybe the same factors that you saw under microeconomic factors in India, when you bring them to the Ghanaian context, they will come under regulatory factors. And once again, this is where what I said, your experience will count. Your experience will really count. So please, the context is very important. The same factor, the same variable can be explained, can be put under different groups, under different categories or components based on the context. So please contextualize your explanations. That is why one of the things I've come to see that in most cases, because I do a lot of review. I review papers. I pass comment on a number of papers for journals. One of the things I've come to notice is that most studies are rejected. Most studies are rejected. They reject a number of studies from Africa, Ghana. I mean, when I say Africa, outside Ghana, they reject a lot of studies from Ghana, and I have even rejected a study from Ghana before. And one of the reasons why I rejected that paper was that you see that the person has explained the thing, but the person didn't contextualize the thing. You know, you are looking at, let's say, the factors that influence sustainable construction, and the study was or is being conducted in Ghana. And you see the explanation that the person has given. The person has given some kind of general, global meaning or explanation to the thing. The thing is not contextualized. We want to know what is happening in Ghana. If the study is about Ghana, what is happening in Ghana? That's what we want to know. Contextualize it. You get my point? Contextualize it. if there's plan, if the because Ghana is not the only country, or you are not the only person conducting a study on sustainable construction. Many people have done studies on sustainable construction. If it is about AI, barriers of AI, you are not the only person writing a study on barriers of AI. Many people have written studies on barriers on AI. If you are talking about other things, you are not the first person. So what you have to do is that contextualize your explanation or your discussion, and that will make your work different from others. And this will come back to answer what Ima asked, that you see the same factors which were applied in a different geographical area is also being applied differently from another geographical area. It's allowed. And the reason why it's allowed is that if you do a little bit of a comparative analysis, you see that the explanations are different. The scholars have contextualized the factors. So when you even talk about something like inflation or interest rates, the person has, or the scholar or the authors, they have contextualized the thing, because the interest rate that is affecting projects in Ghana may not be the same as the interest rate affecting projects in Australia. So please, I want to encourage each and everyone. It's one of the reasons why most journals, they reject papers, because sometimes we read a paper and you don't see anything different. Your study is about Ghana, but there's nothing Ghana in the thing. Well, especially the discussion part, there's nothing Ghana. We want to know what is happening in Ghana. If you are going to just explain it based on, say, inflation rate or interest, inflation rate affects every country. There's no country that is not affected by inflation or interest rate. There's no country currently that is not using some form of AI. Everybody's using AI, but we want to know, in the context of your country, in the context of the area that you are conducting the study, we want to know what is happening, and that will make your work stand out. And this is where your explanation of the factors will be important, or this is where the explanation of your factors will be different from what people have already done. So Ima, I will encourage you, and I want to encourage all of you here, please, when it comes to the discussion part of your resource, try as much as possible to contextualize things. This study that I conducted is a global study. So if it is a global study, you are free to cite anything, say anything, because it's something global that is like you're assuming it's going to affect everybody. But if your study is a study about, let's say, Ghana, Nigeria, Hong Kong, Canada, please try as much as possible to contextualize your work, and that will make your work stand out from all the other papers. Yeah. Please, any other question? We have 10 minutes more to end the meeting. Any question concerning what we have done today? Any question? Is it easy? So I want to just take you through the whole process. I want to take you through the processes again. Just a summary. I want to summarize and conclude. So the processes include that already you are doing part of it, so I will not bother you. You're already into data collection or data collection. So once you collect your data, the next thing that you have to do is that you have to do some kind of descriptive analysis. Within the descriptive analysis, we'll be able to get to know things like how many respondents and the kind of jobs that the respondents are doing, like the kind of job positions that they are holding, where they are coming from, the managerial experiences in terms of the number of years that they have worked. If it's a global study, which countries are they coming from? and also other basic things about the respondents to be good. That's the first part of your survey. That's what I mean. Then the second part is that you now do some statistics concerning the mean of your data set. So I want to show you where is that. You have to put the mean of your data set, the standard deviation, and all that, and you go ahead to do the ranking. In fact, there are many ways by which you can do the rank. Apart from the mean, you can also use what we call the normalization approach. Normalization. If any of you want to learn the normalization approach, it's the same mean, it's just that it's the same approach anyway. There's nothing different about the normalization approach. There's nothing spectacular, special about the normalization approach. You can use about it at the end of the day, is the mean that you are just massaging it and you are changing things here and there to give you that. But for me, to make things simple and easy, just use the mean to rank. And if you want to read about the normalization approach, I recommend you reading a paper written by Dr. Sechi, the FSE PPP project, the FSE synthetic evaluation. A paper written by Dr. Sechi. Yeah, so you can go through synthetic evaluation if you want to learn the normalization. But I just don't want to bother you with that, because at the end of the day, it's the same mean. So please, to make things easy, simple for you, just use the mean and go your way. But if you want to make your work look like it's kind of, some people say special, but it's actually not special. There's nothing new, it's the same thing. You can read this paper, okay, from Dr. Robert Osage. Okay, yeah, let's see. But how to run the normalization. Then you rank. And also, if you want to also conduct some form of test in terms of trying to determine the differences in the responses, then you can either conduct the Kruskal-Wallis test, or you can conduct the Mann-Whitney test, or any other test. Once you are done with all that, you can put them in this table and present. So that's the first step. The next step is that you go ahead and conduct your exploratory factor analysis. So with the exploratory factor analysis, just like what I showed to you in the results, this will help you to determine the groups, the main reason why, and please, each of them give a reason, each of the statistics that you conduct, give a reason. Because one of the reviewers, I remember when I submitted this paper for a review, one of the reviewers asked me, why did you conduct the exploratory factor analysis? What's the purpose? So give a reason why you have conducted each of the tests. Why? So if you look at my paper, I have explained why I put the Shapiro-Wilk test. Not just there. There's a reason for that. Why I put the Kruskal-Wallis. So each of them explain. The same applies to the factor analysis. Why factor analysis? What's the purpose? Why didn't you conduct the analytical hierarchy process, which is AHP? Or why didn't you conduct the confirmatory factor analysis, but you decided to conduct exploratory factor analysis? Give a reason. So here, the reason why the exploratory factor analysis was conducted was to determine the factor groupings, the components. That's the main purpose. We want to know the groups. So once the factor analysis was conducted, the next step was to determine what we call the weighting function. The weighting function. Here you can see from this paper that I conducted a confirmatory factor analysis as well. One of the reviewers wanted me to confirm. One of the reviewers wanted me to confirm the. One of the reviewers wanted me to confirm. Okay. One of the reviewers wanted me to confirm the factor groupings. So I use I did a part of it because I didn't want to show everything. So I did part of it. And this is not part of our analysis. And you don't have to do this. Yes, you don't have to do this. Yeah, don't do this because I don't think they will ask you to do, the reviewers will ask you to do this. Yeah, but this one, the reviewer just wanted me to confirm and see whether the factors in each of the groups indeed they fit into the groups. Yeah, so that's why I conducted this confirmatory factor analysis, but it's actually not something that you have to do. It's not important. Good. So once you have your weightings, once you determine your weightings, individual weightings and the group weightings, the next thing to do is to determine your membership functions of the individual membership functions and the group membership functions. And I've explained that if you want to know the membership functions, what you have to do is that you have to know the number of people who agreed or disagreed or responded neutral and whatever to each of the variables. And based on that, you can determine your individual membership functions. And once you have your individual membership functions, you can go ahead and determine the group membership function. How do you do that? You multiply the individual membership function by the individual weightings from the previous analysis. And that will give you the group membership function. Once you have the group membership function, now you can go ahead and determine the critical index. How do you determine the critical index? One, you can determine the overall critical index. And if you want to determine the overall critical index, you multiply the group membership function by the group weightings. And this group weightings also is from the previous analysis of the membership of the weighting functions. Once you determine that, you can also determine the individual critical index. How do you determine the individual critical index? So what I'm going to do is that I'm going to share this. Once we are done, Ima, I'm going to share this with you because, as I said, everything is transparent. Because this paper, this data set is on this paper. I also have this one. I'll share the two with you. The main purpose is just for a guide. It's not you just to guide you. It's a paper I published like about a month or two ago. Yeah, this paper. Okay, so the data set I used to, or the analysis that I did, I have the Excel sheet, and I also have the Excel sheet for this paper too. For this paper too, I have the Excel. So I'm going to share these two Excel sheets with you. Please, the purpose is to assist you as a guide. It's not for you to copy or something. It's just for you to understand it and know how to go about it. Okay, so this is the one. Yeah. Right, probably I think a month or so ago. Yeah. So good. So once you know each of the critical variable, now you can rank them. You rank them to know the one which is the highest. So the highest will be the first, the one that will come second. We have the third, and the fourth, and the fifth. So during the explanation, which will come under the discussion section, you have to explain. You have to explain each of the factors. Yeah, you have to explain them. Okay. Yeah. Each of them. I mean, each of the groups. You explain each of the groups. These people, they have put it together too much. I wanted them to separate it a bit. Anyway, but it's easy to see. I'm talking about this. Okay, so please, yeah. Any question, anything, that's all. Yeah, simple, easy. Is there anyone here who has a question? Anyone who has a question? Anybody who has a question? No question? Okay.
I have a question.
Please ask.
Oh, kind
Yeah,
of
go
a
ahead.
concern. So, yeah, the analysis you did justice to it. But it looks a bit complex to be per se. I don't know whether because it's
Okay.
my first time of seeing it, but as you indicated, maybe we have to find locate the tutorials that you've done on YouTube and watch them. Maybe after that, if there's something that I don't understand, maybe reach out to you, because for now, for the one is it 2 hours 30 minutes, I'm seeing things that I've
The
never.
whole thing look like something.
I've I've been lost for an hour now, so maybe
Wow.
I watched the tutorials on
Okay.
YouTube, and then
Yeah,
I can
yeah,
see that
yeah. Okay.
the man was actually on point. So maybe he's having an idea. So for him, he was carried along from the start to the end. But for me, and I know for some of us, come on, was Chinese.
Okay.
Anyways, thank you so much for the time.
Okay.
Yeah.
Oh, okay. So, okay, I want to know something before we go. What was or what is your main issue? Was it the process in terms of going
Um,
about the steps or the
you
content?
know, okay, thank you. It's when you started with when to do that analysis. Yes, I was getting it. But when it got to the practicality, where the interpretation and all of that, I mean, it just became different things altogether. So I understand that. I know these 2 hours is not enough, but as I said, it gives an exposure. Some of the things you've mentioned, I'm sure when I'm following through the YouTube video, I may have an idea, but I can the way I'm lost. You can't explain it for me to get it now. I just have to find my time.
Okay,
Yeah.
okay, I get you. I get you. So I think what you have to do, and I'm going to share the video with you, is that it will be good you rewatch or you watch it again. You watch
Okay.
this
Okay.
video again, especially this video again. But when you are watching, this is one thing. This is one thing I always tell students. When you are watching, please don't just watch. Get yourself a data set. So what I'm going to do is that I'm also going to give you just a minute. I don't know whether I put a data set here, but what I will encourage you to do is that get yourself a data set. I think there was a data set I shared. Okay, the one with the 20, the
Okay.
20 with this one. I'm going to share this data set with you where we got this resource. Please, I'm going to
Okay.
share with you. I'm going to share this data set where we had 20 people, 20 variables, so that everyone, you can just apply what you watch to the data
Okay.
set. Other than that, you've also finished watching and you will even be more confused.
Okay.
Yes. So what I'm going to do is I'm going to share this data set where we were able to get the 6 groups. Okay, 6 groups. I'm just going to share this data set with you. It's here, the data set is here. So I'm going to share it with everyone. So please, as you are watching, you also be doing it.
Mhm.
As you are watching, you'll be doing it. As you are watching, you'll be doing it. So that by the time that you are done, you get a whole thing. Other than that, as I said, you are going to be more confused. Yeah, that's how the whole thing is done. Yeah, don't just watch, just do it. What about Sharon? Are you okay? Esther, I've not heard any of the ladies. Are you okay? Good.
I
Okay,
think we
that's
are
okay.
okay.
Okay. Thank you, John, for. Oh, Eugene. Oh, sorry, Eugene is trying to join. How come I cannot see? Yeah, Eugene, you have joined. Your name, you are here already. Oh, I can see your name. Because he put it on the page that he can't join. I can see your name here. You are already online. Sharon, please, are you okay? Oh, this look like somebody will say Arabic
Sharon,
to you. I'm sorry. Okay. Okay, yeah. So please, the what I will encourage each and everyone to do is that please, I'm going to share this video with you, but put a thing into practice. Other than that, you watch and you won't get anything. That's the thing. In fact, the best thing I wanted each and everyone to do was that I wanted you guys to finish the data collection and then bring your data set, and then we do it together. But the thing is that if I also decide to do that, I think we are going to waste too much time. So I want to just give you like an advance support before all the data sets will come in. Once you get all the data set, then you can easily go ahead and do your own analysis and all that. So that's why I decided to do this. But the best thing, and the last circumstance, is for you to get all your data set, just like the 20 data set I'm going to share with you. And then whilst I'm doing it, you also be doing it at the same time with me. That's the best way to learn this, because all the people I've taught them in the past, they had their data set with them. Whilst I was doing it, they were also doing it. So by the time that I ended, they have been able to grasp the whole thing. But you guys, I want to give you a head up or head start or an advanced support, so that by the time that all your data sets are in, you already know this. And once you get a data set, you can run with it easily. Yeah, so that's the reason why I decided to do this. And I think it's the best thing to do than to wait for the data set to come in. Because some of you, your data set may delay a bit because maybe the people are not responding and all that. Yeah, so that's it. So any other question? Thank you very much. In fact, I'm happy you guys were able to come. It was so far since so far so good. If I can say, even though, as Alphonsus and John said, there's something more to be done, and that thing to be done is to apply what you have been able to get here to a data set. Yeah. Any question before we go?
I think
Any questions?
we are okay for now.
You're all good for now. Okay. So thank you so much. And yeah, so I'm going to share once again. I'm going to share I'll say 4 things with you. 4. The first thing is the 2 articles. That's the first thing. Then the second thing is going to be the data sets. And then the third item is going to be the Excel sheets. So I'm going to share the 2 Excel sheets with you. Yeah, because I mean, it's something that I have done already. And then the last will be, I'll also add some studies. But I don't want you to, even though I want you to focus on my 2 studies, but I also want you to read other studies as well. Yeah, because as you read other studies, they will give you another dimension, another perspective of how to go about this. But at the end of the day, they will all come back to the same soup. As somebody will say, we come back to the same point. So I'm going to give all these things to you, and then you use them. But please, once again, please don't say that, oh, I'm going to wait, later I will do it. Please, after today, anytime that you get opportunity, just apply, do it. Do it. Because you master it when you apply it. Yeah, even me myself, it took some time before I got this, to be honest. I didn't get it one day. Yes, I didn't get it because I remember one professor who is now a professor, Professor Wuni. I think I've introduced his studies or papers to you. He has written a number of papers on using the FSE. Yeah, Wuni has written so many studies. Yeah, so you can check Wuni's papers. He has a number of studies using the FSE. I'm using FSE. So I remember he taught me. I had a meeting, just one-on-one meeting with him like this. In fact, after the meeting, just like some of you are saying, I didn't get the meeting. It took almost about 6 months before I got it. Yeah, but at that time, The reason why I think I didn't get it at a go was that I had other things because I was doing my PhD and my supervisors were on me, blah, 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 and all that. But I think all things being equal, you guys, you have some time. So when you get any little time, watch the video, apply it. Even if you are not able to apply or do all the sections, just learn little by little. For example, today you decide to learn the mean, how to go about the mean, how to run mean, or how to determine the mean. Another time you do this, another time you do that, another time you do SPSS. So by the time that you realize within a month or so, you will get through it. And once you get one, or once you understand it, you can apply it to many papers. You can apply it to many papers. Yeah. Okay, thank you all for joining. Please, our time is up. It's almost like 3 hours. And it was great meeting you all the best. Please, I'm always available. If you have any question, don't be in your corner and struggle. That's what I don't want. I don't like. Don't be in your corner and struggle so that later on, oh, I didn't get this. And always try as much as possible to approach me. And if there's a need for me to even schedule one-on-one meeting with you, I'll do that and support you. Yeah. So all the best and take care. Bye.
You didn't talk about the KMO. The KMO.
Thank you very much, Doc. God bless you.
Yes. Is somebody asking a question or something?
You didn't talk about the KMO. The KMO. I don't.
The KMO. The KMO is part of the exploratory factor analysis.
What is the benchmark for that? The benchmark.
The benchmark.
For the KMO.
Okay, the KMO and the Butler's Sphericity. Once you get a significance, once it's significant, we don't really have a threshold for that, but always check the significance level. Once you get a significance to be maybe 0.00000 something, normally the significance level is 5%. So once they fall within the significance region, then the value is not that important, but the significance value or region is what you have to check. So if you get a significance level of, let's say, 0.00000 whatever, and it's significant, that's it. As for the particular value is not important because they differ or they vary depending on the data set that you are using.
Thank you.
You're welcome. Okay, then please take care, everyone. Have a great weekend and all the best.
You too, though.
You're welcome. Bye.
Okay, bye.
Thank you, Doc. Bye.
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 Bye, dear man.
Tracy Sinwadana.
Yesterday. Ima, you are still here. Okay. Bye-bye.